Anybody donating blood today? No, nobody? I might as well. I mean, when you donate blood, don't you like sit in the chair for like 25 minutes or something?
Yeah.
I mean, it's like a long time, right? Well, I went in this morning just to my doctor. I'm not altruistic. They took my blood. 21 vials for all the different tests there. I got like 3 different doctors ordering stuff. 21 vials. And I mean, I don't think there's anything wrong with me. This is like routine stuff for all my meds. He was just emptying it into a pitcher. It was I mean, it seems like, do you have that much blood? I mean, maybe that's the thing, is those vials seem like they hold more than they actually do.
Like they're really skinny.
Yeah.
I remember one time in high school I donated, and like normal was like 1 pint, and then I donated 2, and they said like, if you want to come back in a couple hours, get a third. That's all right. You do it fine. I'm like.
But so you just sat there forever,
Yeah.
like playing like Game Boy or something like that. Just your Game Boys. Do they even exist anymore? Game Boys?
I still have mine.
They just don't even make DS now.
Okay.
They're like 3DS or something.
See, I remember the original monochrome Game Boy, like the day it was released. Came with Tetris. Then what was the Super Mario one? There was the Super Mario version of that came out. Isn't that funny? We wouldn't play those now, right? You wouldn't play like just monochrome, like the original.
The color.
Oh, like the original Game Boy Color,
Yeah.
or like.
The original one. Yeah.
Oh, really? That's pretty kind of sad, actually. just call him the way I see him, I suppose. All right, so let's do this. We'll go ahead and let's just start a new project. So I'll close all these guys. We'll go ahead and create a new Java project. We're going to call this guy CSC200 Spring 2016, just as our placeholder. And we'll create a new class in here, and we'll go ahead and name it driver, like we've been doing for some of the other ones. All right, we'll go ahead and write our main. Okay, so last class we introduced a couple of the methods associated, well actually it looks like we just introduced one at the very end of class. So we have a method called length that allows a string to report its length, how many characters in a string. And this guy does not have static in front of it, so I've advertised it. So this follows our rules of declaring a method. Here's your return type, here's your method name, here's your parameter list. In this particular case, length takes no parameters, and there's a good reason for it. It's related to this word here, calling. So what the length method does is it reports the length as an integer of the calling string. So let's give some context for that here. So I'm going to come out here. We're going to create 2 variables, string hello, well, string s hello, string s2 is equal to elephant. Now if I do system.out.println s versus system.out.println s2, and let's call s.length s2.length. In this particular case, this call to length, the calling string is s. This call to length, the calling string is s2. All right. Actually, you can take it a little deeper than that. It's the contents of s that is the calling string, not s itself. S is a variable that happens to hold a string. All right, so the calling string there is actually the contents of S. And to kind of prove that to you, we'll do LOL.length. So now I chose not to store this string inside of a variable. Instead, I just gave it a string literal. All right, so when I say LOL.length, the calling string is the string LOL, and his length should be 3. Make sense? So we'll print this out. So this should be 5, 8, and then 3. There's our 5, 8, and 3. So each call to length operates on whatever string called that guy. Make sense? So that's what I mean by calling string here. And that's also why this guy does not have static in front of it. So we started talking about this last time. Static versus non-static. When we say something is, let's write this. So when we say something is static, we mean it is owned by the class in which it was defined. Okay, owned by the class in which it was defined. Now, these don't just pertain to methods. It can also pertain to variables, which are called fields. But in our world right now, we're going to assume that the things that are static are methods. Okay? So we call them by using the name of the class in which the method was defined. And realistically, in the correct way of saying it would be the member was defined, because we have two different things that could be static, but in our world right now, we're going to assume it's only methods. So as an example, this would be class name dot method name, and then whatever parameters it requires. That's how you would call that guy. As opposed to non-static, it is owned by an instance of the class in which it was defined. This guy is called by using an instance of the class in which the method was defined. That is instance dot method name params. Okay, and let's view the two examples here. By the way, the contents of this slide would make an excellent quiz sometime soon, FYI. Okay, so that quiz would involve something along the lines of static versus non-static. What does static mean? What if static's not there? Static means it's owned by the class. Not having static means it's owned by an instance of the class. How do you call static methods? Using the name of the class in which the method was defined. How do you call non-static methods? Using an instance of the class in which the method was defined. All right, so similarly, if I were to give you a method header and ask you how to call this, you should probably be able to show me how to call this. But I would more than likely ask the quiz question in the short run, maybe next class, for example, related to kind of repeating these statements back. Static versus non-static, those guys. So kind of like when we talked about Boolean earlier in the semester. So a Boolean expression is any expression that boils down to a single value of true or false. We want to kind of ingrain that into our soul. It's going to be important from a programming perspective moving forward. And one of the reasons for that, as we're already seeing in here, is the large portion of learning to program is the problem-solving aspect of it, not the language itself. We've made this transition from Alice to Java in about a week, and we probably like the brand new language better than we liked Alice. All right, so even though it's, we barely looked at it, gives us a little more flexibility or less control. Alice has less control over your clicks and that kind of stuff. But the language itself isn't the important the important thing. It's the problem solver. We're using the same kind of problem solving regardless of the two languages. Similarly, our general purpose modern programming languages are pretty big. So the chances of us having the entire language memorized is pretty slim. So I've been programming in Java since the day it came out. And I would guess that I know I've probably seen less than 20% of the actual language. Now I've seen the entire core language. You know, the stuff that we basically made our primer for the other class, right? Okay, but there's a zillion. I mean, have I shown you the Java documentation in here? Let's just quickly look at that because it's so java.sun.com. That dates, because Sun is no longer a company. They're owned by Oracle, but I still go to java.sun.com to get the documentation. Then you go down here to Java SE. Then you go to Java APIs, and then pick one of the top couple. It doesn't matter. In general, you're using the stuff that's not part of that, or that's been around for for the last 9 versions. All right, so here's the organization of the Java API. In the upper left-hand corner, these are all the packages that exist in there. Okay, those are collections of objects. Not objects themselves, but collections of objects. The one that we have access to it, the core language, really the thing we're talking about right now, is java.lang. This guy right here. That's the core Java programming language. Okay, we've also looked at java.util because we had to use scanner once, right? So we've looked at a couple of other ones, but java.lang is the core language, and we don't have to import anything. It comes with Java. But the point I was getting across here is down here, these are all of the classes that exist in the Java programming language. You can see we're not very far down here. So rounding down, there's a lot. Okay, so I think I'm actually probably being aggressive when I say I've seen 20% of these. It's probably more like 10%. And I've been programming in Java since the day it was available to people. All right, so punchline there is the chances of you memorizing the entire language is basically nil. You're not going to do that. So instead, we have to have the skill set to be able to read the documentation. So for example, and this is related to what we're doing today, if I go to java.lang, you'll see a much smaller collection of stuff here. This is the core Java language. And we'll go to the string class here because this is the guy we're actually working with. And here's all the stuff that strings can do. There's some description stuff at the top there, but for all intents and purposes, where our world starts is right here under the method summary. Okay, and notice right off the bat it gave us a combination of static and instance methods that we can click on, but generally speaking, you're going to shop through them this way. We're going to look at charAt today. We're looking at length right now, so let's just go down to length. So here's length. So when I look at this method, here's the method name, here's the parameter list, this is what it returns, and we do not see static over here. So since we do not see static over here, we know everything we need to know in order to call this method. Okay, we know what class it's defined in. It's defined inside of the string class. We just scroll up to the top here. We're looking at class string. So that's the class it was defined in. It doesn't have static in front of it. That means it's an instance method, which means it's owned by individual instances of the class in which it was defined, which in this case is a string class. So like in our code here, we've defined 3 different strings. 2 of them we chose to store in variables. The third one we just used as a string literal. All right, and each one of those gets their own copy of the length method that knows everything there is to know about that particular instance of the string class. Make sense? All right, so that's what instance methods are, instance members are. Now we go back down to length. Okay, so over here, just looking at this one section of the screen, we get used to looking at the documentation. This tells us everything we need to know about who owns it. This is owned by an instance because we do not see static there. We know it's going to return an integer. Here's its name. Here's the parameters as it expects. In this case, this guy expects 0 parameters. This little section right here tells us everything we need to know about how to call this guy. We need an instance of the string class, and we call it using that instance, passing it no parameters. Just like we've done right here. Instance of the string class, method name, still requires a parameter list with nothing in there. Instance of the string class, happens to be a different instance, so on and so forth. Make sense? So that's an important skill set, being able to read and use the documentation, because there's no way you're going to memorize the entire, the entire language. So then that allows you to kind of play, if I go to all classes here, let's just randomly pick a class, and I'll make a guess as to whether I've seen it before. Here, we'll go, oh, constructor class. I don't know if I've actually ever used that. Let's see what this guy can do. So here's the method summary. So we have equals. So, if I have a constructor, I can check to see if one constructor is equal to another object. So this guy's owned by an instance. It returns a Boolean. Its name is equals. I have to pass it anything that is an object as a parameter. Another function, get annotated receiver type. I know I've never used that guy. Takes no parameters. It returns an annotated type. It doesn't have static in front, so I need to call it with an instance of the constructor class. All right, so being able to read this documentation is going to open up things for us. And then you just got to figure out which. So now the real challenge is what tool exists that helps us solve the problem that we have in front of us. So first rule of thumb for us is, and we've said this several times, we always solve our problems in the tools that are currently in our toolbox. And for us, we want to keep going down that path. Eventually, once we get enough experience, if we don't have a tool specifically in our toolbox and we suspect that the problem we're trying to solve is a relatively common problem, we then might decide we're going to go and hunt for a particular object or something like that that's already been written that allows us to solve that problem, rather than writing our own solution for it, or at least solve the problem in part. Okay, so think about that like if you're doing some construction stuff in your garage and you need a certain tool and you don't actually have that tool laying around, but if you grab 3 other tools and kind of hold them together in a dangerous way, you might be able to accomplish what you're trying to accomplish. But if it needs to be done right, you might decide to make the trip over to Home Depot. All right, so yeah, I ran into that problem yesterday, actually. I was taking the prop off of my motor on my boat, and I didn't have the right size socket, so I decided to MacGyver it, and that did not work out well because those things are on there really tight. And so I finally decided to make the trip to Home Depot. It's a long drive too. I live 2 blocks away. Yeah. So and the correct tool costs $3. And I spent about 45 minutes trying to pry this thing off. Oh yeah, yeah. You can always return it after you get the nut out. It's like wrong size, but I'm gonna keep it because I might need to take that thing off again. But yeah, kind of interesting. I think that might actually be a guy thing. Yeah, we're pretty stubborn. It seems like. Yeah, I can't imagine my wife ever doing that. I think she would look at it and say, okay, well, this is what it takes. I'm going to go and find the correct tool for this, rather than possibly cutting your hand off because the blades on the thing, they're sharp, especially when you've hit some stuff and there's like big chunk cutouts from it. It was dangerous what I was doing. Yeah, well, not as cool as Guatemalan prison, but close. Yeah, good thing I didn't get that upset. I would have shifted to the Incredible Hulk mode and then probably would have ended up ripping the motor off the back of the boat, which would be problematic because that motor is already illegal. Yeah, it's way too big for that boat. But you can't find motors for boats that old. My boat's a 1978 boat. So I took a 1978 motor off of it and which didn't work anymore. Put an 85 motor on it, and it weighs less than the other one probably, but it's too much horsepower. Too many horses. That's right. So I'm just waiting for the day when you gotta like rev up kind of slowly, otherwise the back of the boat will rip off. All right, so
Hopefully not on your trip across Lake Michigan.
well, hopefully you end up getting up to speed, like close to shore, and then you just maintain speed the entire way across, no matter what kind of waves you're hitting. just jumping and slamming down. And did I tell you it's actually illegal?
Yeah.
Did I tell you that story? Yeah, I'm gonna still do it. Yeah.
You might be too small for them to detect you on radar.
That's right. I have to fly, come up with my own country name and just decide these are international waters. Actually, is it international water? You're on Lake Michigan? It might be. I can become a pirate. All right. So, in any case, reading documentation is a pretty important skill set. So, that trumps, pun intended, I think. Okay, that trumps memorizing stuff. Okay, so the things that I'm telling you to memorize are the things that are actually important to memorize, and it's a very short list. For the rest of the stuff, you're going to gain, I guess, that memorization model through practice. Okay, just like a sport. This goes all the way back to the beginning when we talked about how programming is kind of like a sport. Okay, so that's static versus non-static. So we've seen the length method here and how we call that. So again, let's go look at the documentation real quick so I can introduce that charAt method to you. So another method that we might be interested in is this guy right here. This lives in the string class. Its name is charAt. It takes a single integer as a parameter and it returns a char. And there is no static here, therefore we call it using an instance of the class in which the method was defined. So the charAt method returns a specific character from within the calling string at index, whatever index I pass it. And it's a zero-based index just like arrays. So let's add this to our list. charAt int index returns the char at position index in the calling string. Okay, again, this is a non-static method, so the calling string is important to this guy. All right, so that's what charAt does. Let's see that in action. So if I say s dot charAt 0, that's going to give me the h. charAt 1 is going to give me the e, so on and so forth. There's the h, there's the e. Allows me to extract individual chars from a string. Does not remove them from the string. Just gives me a peek at a portion of the string. Make sense? All right, so now we know how to get the length of a string. We know how to get an individual character from a string. How can we write the necessary code to print out every single character in a particular string? We're going to do this as a function, and this will allow us to compare static versus non-static, because as far as right now is concerned, we know about static methods. So we're going to write our own method here called that's going to be a static method. Therefore, it's owned by the class. Therefore, we'll call it using the name of the class in which it was defined. This guy's being defined inside of a class called driver. So we're going to say static void. It's not going to return anything. It's going to display some stuff. Display string. And this guy will take a string something as a parameter. All right, actually, let's, well, I'll call it string s, but understand that this s is different than this s because of scope. This s lives and dies with this variable scope. This string s, its scope belongs to the display string method. It's only alive for the duration of this method here. So I can name this guy whatever I want, but whatever I call him, that's how the parameter is going to be used inside of the method. All right, so this method is going to be called display string. It's going to take a string as a parameter, and this guy should display the contents of the string, one character per line. All right, so a couple questions about this. First of all, this is the only part of the world we're looking at right now. Okay, so forget about the stuff above. All right, so just what I have highlighted. How many characters are in S? Remember, methods are reusable chunks of code. We write them once and we can call them multiple times. So the value, the parameter we pass to this guy is variable, right? We can pass hello to it 1 minute. We can pass elephant to it another minute. We can pass any string we want to this guy. So my question for you is, how many characters are in S? Not a trick question? Oh, you look like you're about to give me a wrong answer. Go ahead. Oh, good. Good wrong answer. Yeah, I like that one. Now remember, the entire world, I've highlighted our world. Here, if it makes you feel better, we'll copy this. We'll create a brand new new class. Let's call this guy test, and we'll just delete everything there. There we go. So, okay, now, quite frankly, our entire world lives in here. Okay. How many characters are in S? All right. Another good wrong answer. Why would you say none? Well, that's true. I haven't. Well, we don't necessarily know that. This is the definition of our method. We haven't called it, but we have to write the logic for this method in terms of the information that was provided. Somebody is going to call this method and pass it a string. So I need to be able to use that string inside of here. One of the things I'm going to need to know is how many characters are in that string. How do I find out that information? String length. We've introduced two methods of strings. You had two options to choose from. So how many characters are in S? S.length number of characters. If I happen to pass it hello, S.length would be 5. If I happen to pass it elephant, S.length would be 8. If I happen to pass it LOL, S.length would be 3. Make sense? Okay, so the number of characters in S is S.length number of characters. So let's get rid of this guy since he... All right, so now that we've established that, well, here, let's just start off with system.out.println s.length. So now if I call display string, passing it s, this guy should print out 5. If I call display string passing it s2, it should print out 8. All right, first of all, is this guy a class method or an instance method? Class method. How do you know? Static. Okay, it's a class method because the keyword static is there. How do you call class methods? So we know it's a class method because the word static. How do we actually call class methods? All right, you were on a roll. Driver dot. Using the name of the class in which the method was defined. How do we call class methods? Called by using the name of the class in which the method was defined. This particular class method was defined inside of the class called driver. So we call it by saying driver dot display string, and I'll go ahead and pass it s. Driver dot display string, we'll pass it s2. Okay, so now I've called it twice. It's a class method. Therefore, we call it using the name of the class in which it was defined. Driver dot, here's the name of the method. This method takes in one parameter, a string. The first time I called it, I passed it S. The second time I called it, I passed it S2. What is S? Slight trick question. We've already mentioned it, but I'll ask it again just as a review. What is S? What kind of animal is S? Go ahead. You're on the right path here. Okay, so S is a variable that happens to contain the actual string. All right, so if we were to identify what S is a variable. At runtime, S will resolve to its value. And its value in this case, or what it contains, is hello. Make sense? All right, so we're going to call display string, but in practice, in reality, we can say that S is a string. S2 is a string because we know that's what it will become at runtime, right? It's a container. We're going to open up the present at runtime and actually get what's inside of it. All right, so the first time I call display string with S, this guy is going to, S is going to pass into this variable right here, which also happens to be named S, but those are different S's. Okay, I might as well name this guy LOL. And then I would say LOL.length there. Understand that this is a variable name, not the string LOL, like we had before. Strings are surrounded by double quotes. Variable names are not. All right, so whatever the string is will resolve to its value, which then gets passed into this parameter and stored locally inside of this variable name, which then we can use inside of display string where the scope of this particular parameter lives and dies. And what are we going to do? We're going to print out the number of characters in whatever string was passed to us. So this should print out a 5, then it should print out an 8. 5 and 8. All right, so that proves the s.length thing. All right, now, what we actually want this function to do, though, is we want it to display the contents of the string one character per line. Right now, we can display the contents of the string all on one line just by saying system.out.println. So there's our hello and there's our elephant. But that's not the output we actually want for this. We want to say H, then E, then L, then L, then O on separate lines. Do we have a tool that allows us to extract individual characters from a string? We only have two tools as it relates to string. We've used the length one, and now we have the charAt guy, right? All right, so we have something that allows us to extract the very first character for, well, any character. Let's look at it for extracting the very first character. S.charAt0. So S.charAt0 for S is H. S.charAt0 for S2 is going to be an E. So this is currently going to display H and then E. All right, but now we want display string. Let's go ahead and just have display string happen one time. So this is going to show us an H. Then an E. Then an L. Then an L. Then an O. That's the output we actually want. But what's wrong with this current method as we have it written? Yeah, this is, even though, so it's not a very generically written method. It's a method that will only work for strings of length 5. Technically, it won't crash for strings that are larger than length 5, but it's only going to give us the first 5 characters. Okay, and for strings that are shorter than length 5, things are going to go south quickly. Okay, so for instance, if I call this guy with our string LOL, it's going to print out L, then O, then L, and then as soon as it tries to access bucket 3, things are going to be problematic. That's going to give us a array index out of bounds error. Okay, a string index out of bounds error after we got our LOL. All All right, so this guy is not very generic as currently written. So this is probably not going to fly for us. So how do we rewrite the contents of this method so that it generically displays the contents of S, one character per line, regardless of how long S is? Good.
Set a loop or set an integer for the length, and then set a for loop for that integer.
Okay, so the length tells us how many characters we're going to have to go through. We're going to need a loop because we want to repeat effectively this line a bunch of times, right? Changing this value in there. So it's not always 0, it's going to be some counting variable. So let's just steal this line for a moment. All right, so we're going to create a for loop. That's going to loop through. It's going to start I off at 0. It's going to keep going as long as this Boolean expression is true. This Boolean expression says, is I less than s.length. S.length is the number of characters in the parameter that was passed to this string. So if it was 5, we're asking, is the current value of I less than 5? If it is, go ahead and print out s.charAt I. First time through, I will be 0, then I will be 1, then I will be 2, then I will be 3. Why? Because each time we're adding 1 to our I and updating the value of I. So understand we can't do just that. I plus 1 boils down to the number that is 1 greater than I, but does not store the result back in I. Okay, so that doesn't actually store it. That's when we need the assignment operator, the single equal sign, not to be confused with the double equal sign. That is the equivalence operator that we have in our primer and we talked about last time. All right, so this loop will take I on a voyage between 0 and s.length minus 1. S.length minus 1 is the last legal position in S. Go ahead.
See, I'm confused with I. Like, are you setting I to the bucket 0 in there, right?
I'm setting I to the number 0. I just happen to be using I to reference a position in the string. So I just happens to be the number. I'm holding onto the number 0. Then I'm choosing to use that number with the charAt function. When I call charAt, I'm just passing that number there. It says, I happen to want the character at position 0. The next time through, I happen to want the character at position 1, so on and so forth. I'm just using I to hold on to those numbers, the positions that I'm interested in using. So there are two different tools that I just happen to be using together in an interesting way. Make sense? All right, so, this guy does not dictate that we're going to do anything to a string. This guy just says that we're going to loop through s.length number of times. That's what that says. What I do each time through is completely insignificant related to the string. I could just print out hello world every single time through if I want. Or I can, add some number for no good reason and never print it out. So nothing about this says that I have to do string stuff. I just happen to be using the length of our string to dictate how many times I'm going to repeat. All right, but because of the type of problem I'm solving here where I want to repeat for each character in the string, I'm going to use that counter to access an individual character. All right, so now each time through the string, we're going to print out a single character, and println prints out something and then kicks it down the line, presses enter. What character am I going to print? s.charAt I. So right now I'm only passing this guy hello, so it's going to print out H, then E, then L, then L, then O, all on separate lines. H-E-L-L-O. Okay? Similarly, if I just change S to S2, now I'm passing in a different string. This guy still generically works for any string that I pass it. There's elephant. If I happen to pass this guy in the string LOL, not as a variable, but just the literal, it'll print out LOL. What happens if I pass out the empty string? Is it going to crash? I'm passing it a string of length 0. So the question is, will this crash? And then defend your answer. Okay, you don't think it'll crash. Why?
Because it shouldn't do anything because y equals 0, which 0 is not less than 0.
Okay, 0 is not less than 0. Fair enough. Okay, but do we check this before we do this? Remember we looked at our various loops? We had a for loop, a while loop, and a do while loop. Do while loops are post-check loops. For loops and while loops are pre-check loops. So in this particular case, because this is a for loop, we do check the Boolean expression before we get into the body of the loop. So he's right. This will not crash because the very first time through, we will fail. I is 0 less than S's length, which is 0. 0 is not less than 0. So we'll just skip right past the end of the for loop, and the method ends after doing nothing, except asking a question that failed. As opposed to, if I had done this inside of a do loop, so maybe we do something like int I is equal to 0, do this while I is less than s dot length. And then each time through I can say I is equal to I plus 1. So what seemingly is equivalent, now this guy crashes. All right, so the logic here is the identical logic, but this is a post-check loop. I don't ask this Boolean, this question until after I've executed the body of the loop at least one time. So if I passed in the empty string here, the very first thing I'm going to try to do is I'm going to get the character at bucket 0 in my string. And there is no bucket 0 in this string. So there's my crash. As opposed to when I had this as a while loop, now it doesn't crash. There's no output, but it doesn't crash. So it literally printed nothing. Make sense? All right, so an example of when a pre-check and a post-check loop makes a difference. All right, now let's look at string concatenation. So we're going to go S. So now what we want to do is we want to static void display with spaces. Okay, and this guy will take in a string S as a parameter. And what we want to do now is we want to build a string and insert a space between each character in the string. Then finally print out the final string. So for example, hello should become that. Make sense what we're trying to do? So that means we need to be able to do string concatenation, glue strings together. All right, and the operator for doing that is the plus sign. So the plus sign, when applied to numbers, does addition. The plus sign, when applied to strings, glues. Okay, connects them to each other. So we'll go ahead and we're going to say string answer is equal to the empty string. So we're going to build up our answer inside of our string answer. Okay. Then we're going to loop through every character of S, basically the same loop we used up here. So I'll just steal that loop for. So this is our stock spin through every character in a string loop. Okay. Just happens to be a loop that goes through the number of times related to a string. Each time through, we want to add something onto our answer. So we're going to say answer is equal to answer concatenated with s dot charAt I concatenated with a space. All right, so we're gluing some strings together. Finally, after that for loop is completely done, we'll go ahead and say system.out.println our answer, which we've been building up each time through there. So now no matter what string we pass this guy, it's going to add spaces between every character. It has the side effect of also throwing an extra little space at the very end, but we won't visually see it, so let's not fix that for right now. All right, so here's our display with spaces. Driver dot display with spaces. We'll pass it S. So this should give us our hello with spaces in between. That makes sense? All right. So your homework assignment is to write this display in reverse. This method should display on a single line the input string in reverse. Okay, that is to say HELLO should become OLLEH. All right, but it should work for other strings than hello. Make sense? All right, so as a starting point and as a review for Git in our last couple minutes here, I'm going to go ahead and put this up on GitHub. So we'll go back here. Oh, here's my GitHub here. Create a new repository. We're going to call this guy CSC200 Spring 2016. I'm actually just going to call it that because we're going to do a whole bunch of different stuff in that single project. So I'll go ahead and create that repository. All right. And the only line I'm going to steal is this guy right here. We just have to do that one time. I'll just do the rest from memory. All right, so you need to move into the directory where your stuff lives. So we're moving into CSC200 Spring 2016. Then we're moving into the source directory. So when we type in ls, we should see our Java files. All right, so I'm going to do git init. Now that I'm sitting in the right directory, then I'm going to do git add dot. If I do a git status, we'll see this created one new file. I'll do a commit-m. We'll call this guy the initial commit. I need to go ahead and add my remote. This only is a one-time thing. And then git push -u origin master. So that pushed it up to GitHub. So if I click on this, there's our driver that's up there. All right, so I'll put the homework assignment up. I'll give you this as your starting point so you have some example code. And that's going to be due on Friday.